There we go. Okay, so I have the first agenda item, and Jarvis is also posting something interesting. But yeah, first my item. We have to get through my item first. I was thinking about the two projects that we're working on, and more specifically that I've been involved in recently, about Git performance and about how to frame them and how to explain what we're doing and why we're doing it, because I get the feeling that it's maybe not. Well, it's one of those things where to me it feels a little bit like we started doing them because they were a good idea on some intuitive level, but it's important to also be able to explain why it's a good idea, even if it's after the fact. And I'm trying to come up with that. Um, and I'm going to run a sort of high-level explanation by you, and I want to hear if it makes sense or if it's convincing. So the gist of it is that GitLab or GitLab is hosted on a dedicated Gitly server, Falconario 1, which is an unusual situation. And even though it has a Gitly server to itself, it presents a vertical scaling problem. And what happened in December is that we looked at some incidents around this Gitly server, Falconario 1, and we saw two opportunities to get us more CPU headroom, meaning more vertical scaling headroom. And I think this is the overall theme of the two epics. So the one epic, it wasn't even an epic before, but I made it into an epic now because I realized it had to be one. The one epic is about reference iteration, because we saw in flame graphs that a lot of CPU time went into iterating references. And the other important, sorry about that. Um, yes, so I was trying to paint a picture of what the theme is, and of these two Git epics. And in one of them, it was about reference iteration. And we're in the funny situation that we already had our big win, because we applied the no tag setting on CI for the GitHub or GitLab project, and that caused an unreasonable drop in CPU, which is like a really good unreasonable drop in CPU. And the work we've been doing after that is to understand why that happened. And then we discovered there was a performance problem in Git, and now that is patched. And now we're trying to get that Git patch deployed in production. But thinking about what I expect to happen, I don't expect anything to happen, because the problem on Falconario 1, it's dominated by CI, and CI already stopped hitting this performance problem. So the best thing I think we can hope for is that once this is deployed, we remove the no tag setting on CI and nothing bad happens. And that's a bit anticlimactic, but I think it is a good outcome, and I think it's worthwhile, because it's better if we can just handle this reference iteration stuff without any special assistance than when we need to make custom config settings on CI.
Are we going to notice for other Gitly servers?
So I looked around a bit, and I didn't look at all 60 of them, but I looked at a couple busy ones, and they don't spend nearly as much time in reference iteration. So also it's harder to tell, because if you look at the CPU profile, you see a mix of traffic across different repos, and the reference iteration problem has to do. It's bad for repos with lots of refs, and a repo like GitLab or GitLab, that we've been GitLab creates too many refs, frankly, but it does, and we can't really do something about it. And we've been doing this to the GitLab or GitLab repo for 7, 8 years now, or something, or 9, I don't know. So it's a bit special in that it's has seen it's been used in the GitLab way for a long time. So it's going to be ahead of other repos in having this problem. So I don't know how many other people have this problem in terms of having that many references. Plus, we are very enthusiastic users of our own CI. We have I think Sean mentioned that we have like a parallelism of 200 jobs or something, uh, which is a bit crazy. And I know we're not the only company in the world who has a massive parallel CI pipeline, but not everybody has that. So I don't think there are enough repos with both a lot of refs and both massive parallel CI to notice the difference on this. At least looking at the flame graphs, I don't see this obvious pattern that we saw on Falconario 1. I mean, we won't know until it goes out, but I don't expect the same dramatic, at this point, I don't expect the same dramatic change. And the outcome I'm hoping for, I'm hoping for two things. One, that we can turn no tags off and nothing happens, which is good, but anticlimactic. And the other thing I'm hoping for is that we all notice, and that is a bit knock on wood, I hope that we notice in our daily interactions with GitLab or GitLab that it's faster, because if you do a fetch, when you do a GTK update or something, then you also hit this. And then it's very noticeable, because if you're a human and you have to wait 500 milliseconds or you have to wait 1 second, that is very, like, we are sensitive at measuring, at experiencing these differences in latency. It's just that there's no graphs for how happy Jakob is waiting for a git fetch. So although there is a graph that measures part of the clone performance, and if I'm right, then that will drop. But that is not something, that's not really an infrastructure goal, because that's more about a developer experience goal, or just having happy, well, having happy users is an infrastructure goal, but it's not like we can say, look, we cut the CPU by 50% on all these Gitly servers so we can scale them down and save X dollars a month. I don't think that's going to happen.
Yeah, it sounds like the only way we could actually demonstrate this, the effect of this, is to deliberately remove the flag from our repo first.
And then deploy it.
And then make it worse, and then deploy it.
Exactly. And I don't think we should do that.
No.
So so the way I'm trying to frame it is, we discovered an important improvement that is important for vertical scaling, and a lot of repos don't have this problem, but we have it, so it is important that we solve it. It's also an infrastructure concern, because vertical scaling is our problem. We need to get a bigger server for the thing otherwise. But we already solved it with custom CI settings, but it's better if nobody needs custom CI settings, and that would be the conclusion of that epic.
That way nobody can surprise us if they come from another Git host with CI and have massively parallelized jobs and start doing this.
Yeah, exactly. And I think also, if you take a step back from infrastructure goals and look at company goals, it is also our goal that people just have a good experience with GitLab, and they can throw whatever their workload is at it, and they don't have to do custom settings and do a special work to make it handle their requirements. But yeah,
And doing it this way, we might have helped other Git hosts as well, which is nice.
That too, yes. Yeah, ultimately, this is the best karma, to solve it in Git itself. Yeah. And but it's, yeah, I guess if the moment we pick up another repo, or another repo grows to the level of CI activity and number of refs that GitLab or GitLab has, we might run into a vertical scaling problem, and now we won't, because, at least not because of this thing, because we fixed this. So I'm still working on how to say this in one sentence for an executive summary, but thanks for listening to it. And it sort of carries over to the other epic, where I will have to refine the same story, which is about handling the parallelism of CI clones by using a cache to deduplicate them. And again, that is mainly going to be beneficial, or the use case we're targeting is highly parallel CI clones. So that's going to be effective for GitLab or GitLab more than a repo that gets cloned 3 times an hour. Although the nature of the cache, we don't really know yet uh, how the storage cost is going to work out, and if we can afford to keep a long window of cached stuff. Because if you have a repo that never gets updated, but it's expensive to clone, and every 5 minutes somebody shows up and clones it, and it's still in the cache, then that is also a win. But maybe we can't afford to keep that data sitting in the cache for that long. I don't know yet. Thanks for letting me ramble. And I'm looking, Andrew, like the things I said about Falconario 1 and vertical scaling, GitLab or GitLab presenting a vertical scaling problem. Is that more or less correct?
I think so. I wasn't paying a huge amount of attention. I'll just be totally honest. But like I was listening mostly, and it all rang true. Like there wasn't anything where I was like, yeah. So I yeah, I think
one thing I was curious about was I saw Gregor was doing some recent analysis on like the CI build table and when we'll hit the integer limit for the IDs and stuff, and like we're talking about breaking that table up. And there was a chart of like CI builds over time, which was nice, it's up and to the right, which is good. And I was curious about if, I'm sure this would be a heavy query, but like what proportion of that builds over time is us and what proportion of that builds over time is like everybody else, because obviously we are very heavy users of GitLab CI.
I guess it's likely that it's us. If you would sort them by frequency, that we would be the top.
Yeah, but it's just interesting, like because obviously it's grown significantly over time, like, and our usage has also grown over time, but presumably our usage hasn't grown as quickly as everybody else's usage. But like, how has our share changed over time is what I was curious about there, because the smaller our share gets, the more relevant this stuff becomes for other customers as well. Like at the moment, we are the problem customer a lot of the time.
I know it's already relevant for self-managed instances because I know this from back when I was on the GitLab team, and even before that from when I was in support, that people want to figure out how to people have CI setups that they cannot that create. People need to somehow horizontally scale their GitLab installation to handle more clone traffic, and it's all because of CI. That has been a story I've been hearing for years. And yeah, I think this also addresses that, and this is also one of the reasons why, when I realized that this looked within reach, and I still think it is, but that's why I'm working on it. I don't want to jinx it by saying it is in reach, but that's one of the reasons why it seemed like such an obvious idea to me. That from experience reports or from anecdotes and hearing what people who self-manage say is like CI parallelism is a challenge. Yeah. And that sort of makes sense because I mean, if normal users, if you look only at the surface of your repository, but the moment you do CI, you go into depth of the whole size of your repository. So it's always going to be an expensive request. Anyway, oops, Jarf, you're next.
Thanks, Jacob. Not sure. I wanted to talk about this just because it has like a scalability angle. Apologies if I'm hijacking the meeting a little bit, but I wanted just to kind of share some of my findings with the recent WebSockets problem we had, where we had a thundering herd of connections after disconnects, and it was an interesting thing that happened, which was we issued kind of a typical rolling reload of HA proxy, which causes the HA proxy process to fork. The old process stops binding to its ports and will just like continue to process connections that are in progress after 5 minutes. And then after 5 minutes, HA proxy kills the process. With WebSockets, this behaves a lot differently because these connections are long-lived. And suddenly, if you do the rolling reload on HA proxy quickly, you suddenly have a bunch of HA proxy processes all being killed at the same time. And thousands of clients, reconnecting at the same time. This caused a huge CPU spike on our WebSocket Puma fleet, which then caused a bunch of errors. Thankfully, just for WebSockets, which is not a big deal. I mean, just means that your sidebar might not get updated. But I would say we discovered some interesting things here. And I just saw that Heinrich sees that there's a pull request to Rails that allows for some better backoffs on the client that will hopefully mitigate this a bit. I would say in hindsight, it was definitely a mistake to have a small number of pods servicing the majority of the traffic, because this means that whenever you terminate a pod, when we do an upgrade in Kubernetes, it brings up a new pod. for that pod to pass the readiness check, and then it removes the old one. Well, of course, with WebSockets, the connections are still connected to that old pod. So as soon as that old pod gets terminated, all the connections to that old pod will go away, and all the clients will just reconnect at once. So I think one of the lessons here is that we probably, for these types of workloads, we need more pods to kind of like force a more staggered deployment. That's pretty much it. Yeah.
I guess, thanks. So I guess this is the maybe the only traffic. Is this the only traffic where we have persistent connections like this? Because I guess with get SSH, that's also a persistent connection. But somebody does a fetch, and probably after 5 minutes, they're done fetching their data.
It's possible to hold up an SSH connection, and we always have these very long persistent connections, which is why we have HA proxy kill after 5 minutes of like time for the old, like, because otherwise the HA proxy processes would just stick around forever, because you can create a persistent connection and just leave it open.
I think some people do that as a performance hack, just for their own laptop experience. So they're doing another Git fetch, and there's already a persistent SSH connection to their GitLab server, and they can just reuse that. I've seen blog posts about that years ago. But if that's the case, then that would be a small number of users, because somebody would have to manually set that up. And then with WebSockets, it's more like CI, where you have who knows how many web browsers who are all running the WebSocket client, and we're all going to reconnect.
Yeah, and these initial connection upgrades are like take up a lot of resources, whereas WebSockets itself uses a very low amount of CPU. So it was interesting. We made the decision to isolate this service from web, so it has its own Puma workers. And in the steady state, we're not consuming a lot of CPU, so you don't need a lot of pods. But when you have a whole bunch of clients connecting at once, like, we just can't absorb it. It would have been different if we were serving Action Cable on the web fleet. We might be able to, because we just have a lot more resources there.
We wouldn't have noticed this.
You're giving
maybe,
me PTSD for Gitter incidents where the whole of Gitter went down. And then the big problem was getting Gitter back up, because every time it came up, we would DDoS the site and tear it down again. This happened on like many incidents, and I'm getting the like chills now.
I wonder, so I don't know what the situation was with Gitter. I mean, this is a case where we control the client, or more or less, right? Because the client is our JavaScript code. So we can reasonably assume that only our code is trying to reconnect. So we can try to solve the problem client side. And I think that's what that Rails thing is probably about, that the client would back off. But if you have an uncooperative client, we could also do something like inject latency on the connection in Workhorse. Because if the CPU problem was in Puma, then Workhorse could see these things and say, oh, you're a WebSocket, I'm going to make you wait 50 milliseconds or random.
I think just relying on the JavaScript is the simplest, like least surprising solution to that. But also the other thing that's really nice about the way that we use WebSockets is injecting that latency is not a big deal, because it's not like chat where you're kind of waiting for the next thing, right? It's like if it's slightly delayed, it doesn't matter too much, which is quite nice.
Yeah, I think as we use this more, that might get an issue, but we can cross that bridge when we come to it.
Like 10-15 seconds is probably never going to be like the end of the world, but
yeah, exactly.
You know, where with chat people are like 15 seconds, you know.
Yeah,
so...
there was an interesting suggestion from Craig in there as well, to like never keep the WebSocket connections open for that long on the client side, like always reconnect after a certain amount of time, because Heinrich said something he noticed was that because we only have the 3 pods at the moment, is that the traffic doesn't end up very balanced after the restart, because they all reconnect at one time, and like not all the pods are available at that time, so we end up like
It's exactly the same as the conversation we had about recycling the database connections from the client, from the Rails application to PG Bouncer, because if there's a deploy, it's the same sort of root problem.
So do we have enough control over the JavaScript to do these things? Because Andrew, you were saying making the client behave better is the obvious thing to do, but now we have to wait for a Rails change to make that happen. And that's the nice thing about having Workhorse, is that we have a server middleware layer where we can mess with things, and we don't need the cooperation of the client or anybody, because we sit there, we can do what we want.
Yeah, I mean,
Sorry.
yeah, you go first, Jeff.
Okay, I was going to say, like, we could rate limit this at the edge at HA proxy. We can rate limit new connections, and that would protect Rails from this. But I don't know if that's a good idea. Like,
I really feel like the best way, like if this is not something that I would be very surprised if this is not something that's already in Action Cable, then, you know, as some sort of like pluggable configuration or some sort of backup, because everyone has this problem, and Action Cable is quite well used as far as I understand. And so, like, I'd be very surprised if you can't do this in the client already. And if that's the case, then we should talk about other options. But like, I think that would be very surprising and probably something we should contribute back.
Yeah, all I was going to say, which sort of builds on that, is that like it might be a bit fiddly to get the JavaScript from Rails in patched, but you know, one sort of the hardest that will be is that we create a fork of Rails, we apply that patch to the JavaScript there, we use our fork, we publish our fork of Rails as a gem, we use that, which we've done for other libraries. Obviously, this is a big one, but you know, other sites use forks of Rails, and it seems to work okay for them.
Are the JavaScript assets actually in the gem, or how does
I haven't actually looked at this, like exactly how we'd be able to like separate pulling in the assets from the Rails backend code, but if it came to it, we could do it like just by replacing the whole gem, so it should be possible.
It is less surprising. I think anything that uses Workhorse is by definition surprising, because Workhorse is surprising. But that's great that we figured that out. Thanks for sharing that, Jarv.
So Jarv, one thing I wanted to ask about your last question was self-managed. Like, would this be a thing we'd have to recommend for self-managed as well? Like, ideally, you should use a different endpoint for WebSockets, so you can have because obviously we don't bundle HA proxy with GitLab.
I don't think so. I mean, I think especially after this client change, it's hard to see anyone having the same problem, especially since it will be rare for people to have a separate fleet for WebSockets, right? Like, I think most people are going to have all of their HTTPS traffic serviced by the same pods. So they'll probably have capacity there if this happens. I don't foresee it being an issue for anyone else except GitLab.com.
Cool.
So I just went through Action Cable tutorial that uses straight WebSockets, and so what I was surprised by is there's almost no layer on top of WebSockets. It's kind of raw WebSockets that Action Cable seems to be doing, and so, you know, we might even just be using straight our own WebSocket, in which case we have total control over that. I don't know.
How do you mean?
Looked at the code. So there's a tutorial here of like building an application that talks to Action Cable with a vanilla JavaScript front end, and Action Cable is super basic. So, you know, it doesn't have like the things that, like, say Bayou protocol or socket stream socket, whatever. There's a whole bunch of protocols that are built on top of WebSockets, because WebSockets is basically like a TCP connection, right? So it's pretty basic. And so a lot of people have built protocols on top of WebSockets to give you like a whole bunch of features that, you know, we take for granted these days. But just looking through this tutorial, it looks like WebSockets is like almost like your TCP connection with JSON objects coming down it, right? To give it an analogy. So in which case you've got very easy control over the back off and all of that.
Well, as long as you can, I guess it depends on who makes the connections on the client side. I don't know JavaScript front-end programming well at all, but something has to decide to connect. And
but we might not be using, like, what I'm trying to say is I haven't looked at it, but there's a chance that we're not even using any library other than plain old JavaScript and WebSockets. In which case, like the back off is all up to us.
Well, WebSockets would be, how do you address WebSockets? Is that just
It's just a
function
standard
of the
like
browser
JavaScript
object or something?
Yeah, it's just like
it's so it's the DOM. The DOM has a method
Yeah,
to say, give me a WebSocket.
Yeah, it's a W3C thing, and you can do it without like any JavaScript. And what I didn't realize about Action Cable, sort of this was my point, was that there isn't any like layer on top of WebSockets. It's just like really straightforward.
Yeah. Now, the idea of periodically disconnecting, I think that is a very very nice idea.
The only risk with that is that because it's unlike anything else, you know, like Bayou or socket streams or any of those like protocols that you get.
I don't know what those protocols are, but go
yeah.
on.
So anyway, one of the things that they have is if you disconnect and reconnect, you know, or you go through a tunnel in a train, when you reconnect on the other side, you'll get your data. And with a plain old WebSocket, you don't have any of that. So disconnecting and reconnecting, obviously the likelihood is small, but any events that happen during that touch point, you're going to miss. So the more you disconnect and reconnect, the more likelihood there is of that. So it's just something to keep in mind.
In the context of chat, that's important because you're missing chat messages. Yeah. But I guess we're coming from a place where you have an idempotent communication mechanism anyway, where if you miss an update, you get all these things that changed, like if it's for live updating a web page. So it depends on how we use it, whether that matters that you miss a message.
Yeah, there's another issue with that. Like, and I don't think we're necessarily going with that as like our first option anyway. But there is another issue with that, which is what Jav mentioned earlier, which is that it's the initial connection that has most of the server load, and we would be doing more initial connections deliberately here. So we'd have to trade that off. Like at the extreme point, it's no better than just polling a JSON endpoint with no caching, because like we'd just be doing all the initial work each time. But oh, it's slightly better than that, but you get the picture. So we'd have to trade that off and see what works best. That feels like we might be done. I guess have a good day, everybody, and Bob will assemble the recording.
I'll assemble it. I hope that I get 2 files out of this. If I only get one, I'll add a note to the video that I upload. Sorry.
Cool.
Bye-bye.
See ya. Bye.